Hi, welcome to Innovation Electronics. In this video, I am going to explain electrical vehicle battery production system. So in this project, we consider the electrical vehicle battery. We have to monitor battery status in the sense battery health, as well as health in the sense we can monitor the battery volt, current, as well as temperature also. If any parameter changing, if changing means if any parameter getting critical level, the system will automatically identify and production the circuit in order to avoid fire accident. Okay, fine. So first I'm going to explain the component detail. What are the component used here? So this is a step down transformer which is used to step down 230 volt AC into 12 volt AC, and this is a rectifier circuit. This rectifier circuit is used to convert 12 volt AC into 12 volt DC by using this kind of bridge rectifier, and this is a capacitor. This capacitor is used to convert pure DC, because a rectifier only convert AC into DC. That DC having some unwanted AC signal, which means that rectifier does not provide pure DC. That's why we are using one filter capacitor here. This filter capacitor will provide pure DC. Okay, fine. And then I used one regulator also, that is called 7805 voltage regulator, which is used to convert 12 volt DC into 5 volt DC, because our LCD and Arduino and some current sensor, this kind of sensor need only 5 volt. That's why we are using one voltage regulator also. And this is the buttons, and this is the 16x2 LCD display, and this is the cooling fan, and this is the 2-channel relay used here. I will explain what are the application used 2-channel relay here. And this is the motor. This motor acts as a load, and this is a lithium ion battery. I used 3.7 volt cell in three cells, which means I added, actually the one cell volt is 3.7 volt and 2000 mAh. Here I added 3 cells in series connection, which means these 3 cells are combining, providing 11.1 volt. Okay, fine. And this is the Arduino Uno, which is used to measure the battery volt, and which is used to measure the temperature also. And also I added one temperature sensor in order to measure the temperature. Fine. So the main concept of this project, we have to monitor this battery health only. Okay, fine. Which means if the battery volt getting low, the system will automatically identify and providing charging. If the battery volt is less than 9, because the nominal voltage is 11.1, if the 11.1 battery getting low voltage, which means the battery below 9 volt, the system will automatically identify and making charging circuit. Okay, and then if the battery reach up to 11.1, if the battery full night it show 12 point something, the system will automatically identify. If the battery is full, the system will automatically getting disconnected. Disconnected means the charging system automatically getting off in order to avoid overcharging. Because if you provide overcharging, what happen? The power stored in the form of chemical stage in battery. Okay, if the chemical reaction running again, what happen? The battery getting more heat, which means the battery will getting damage as soon as possible. That's why we have to provide overcharging. We have to avoid overcharging. Okay, and then we have to monitor the temperature also. Temperature is nothing. If the battery getting overheating, which means if the load consume more heat, or if any short circuit occur, the battery getting overheat, that time the battery temperature will rise. So we can easily monitor using this kind of temperature sensor. Here I used 18B20. This is one of the waterproof temperature sensor. We have to fix here. If the temperature getting rising more than critical level, the system will automatically identify and activate the cooling fan. For demo purpose only, I added cooling fan here. Actually we have to fix here. Okay, and this is a load which is used to consume the power from the battery. Okay, fine. Now I'm going to show the demo. So now project is getting on. Okay, now you can see here the volt is 11.1 volt, 11.1. Again I am going to show you. So 11.1, and temperature is 32. Okay, fine. What happened? I simply, if the battery is low, which means battery is getting low voltage, which means below 9 volt, the system will automatically turn on the charging. I'm going to closer. You can see here. Okay, for demo purpose, what I'm going to do, simply I added one switch here. Okay, I simply added one switch here. this switch is which is used to disconnect the battery from the controller, which means for manual testing. And real time we can connect any load in order to reduce the power. For demo purpose, I used one switch in series with battery connection. If the switch is open, the system, the battery voltage is getting 0. That time the quick charging will automatically turn on. I'm going to off the switch. So you can now see here, low volt, it providing low volt. At that time the one relay also automatically getting on, which means the relay providing charging. Okay, fine. And then I have to close here. If I close it, what happen? The battery volt getting high, the system will automatically getting off. So this way we can easily show the battery volt low. And I'm going to show the temperature demo. This is the temperature sensor, and you can see the room temperature is 32, and this is the cooling fan. If the temperature getting on, the cooling fan automatically turned on. I'm going to increase the temperature. You can see here. So you can see here the temperature is getting more than 51. You can see here the temperature getting more than 50. So what happened? The cooling fan will automatically turn on. The buzzer also indicating. Okay, if the temperature is getting low, which means if it's getting low temperature, the system will automatically getting off. Okay, fine. And this is the switch which is used to run the load. We can run the load also. Okay, fine. So thank you for watching. If you have any doubt regarding in this project, you can contact our office number. Thank you.